Today, we're on to the next topic. We're looking at the Azure Firewall solution. Again, this is related to content for the AZ-104, but does also move on to things like the AZ-305 and things like the SC900s and the SC300s and all sorts. This is essential core Azure services. So, Azure Firewalls. This is Microsoft's Azure Firewall. Bearing in mind, there are a lot of Azure Firewall solutions out there. Whether you want to deploy things from F5 Big IP, from Cisco, from pfSense, from Sophos, they're all available in the Azure Marketplace. And to be honest, the Azure Firewall here may seem simple in comparison, but it definitely has its place in the puzzle of your cloud-based solution. So what does it do? Well, it really does something quite simple. It works with SNAT, so it's all network address translation, and essentially it sits in front of your traffic. So when you deploy an Azure Firewall, you have traffic coming in, that traffic is being sent to different services behind here, and we can go in and apply specific rules and policies to that firewall. We might essentially say things like everybody on spoke 1 is blocked for all ports apart from port 80 and port 443. Very easy. We could say that, for example, spoke 2 can only have, port 53 for DNS. And maybe it can only talk to specific IP ranges. You could also implement on here, maybe not just port 80 and port 443, you could also do, for example, a block all DNS requests rule. And you could then allow only certain pages, only certain web pages via DNS. This is actually what we're going to do within the demo in a moment. We could also take our on-premise traffic as well and filter that through the Azure Firewall. So we could essentially take our on-site, throw it up to the cloud, have Azure Firewall do things with that traffic, and then send it out to the internet, so we keep all of our rules in one place. Why would you want to do that? Well, one of the main reasons is here, Microsoft Threat Intelligence. Microsoft can actually scan, or will be scanning, your traffic going through this Azure Firewall. And Microsoft Threat Intelligence has a lot of information about malicious things happening on the internet. So what they're going to do is automatically do things like blocking IP addresses and FQDNs, and also alerting you alerting you if you have malicious traffic flowing through your network. So this Azure Firewall can process quite a lot of information. And in reality, what you will end up doing is you will end up setting up something that looks a bit like this, in the sense that you have an Azure Firewall existing on a hub network, and this will be going out to the internet via its public IP address, out to the big www. And then you could route traffic between this hub virtual network and other networks that are hanging off it. And you would do that by peering these connections. Now, Azure Firewall does come in a number of flavors, and if we go and look at the documentation, we have 3 nowadays. We have the Azure Firewall Standard, which provides layer 3 to layer 7 filtering. Remember your OSI model. All people seem to need data processing. Please do not throw salami pizza away. Application presentation, session, network, data link, physical. Did I get that right? All people seem to need data processing. Okay, let's try that. I can remember this. All people seem to need data processing. Application, presentation, session, transport, network, data link, and physical. Excellent. So this is actually operating from layer 3 to layer 7 of this OSI model. So it's operating from that network layer all the way up to this app layer of this OSI model to go and look at the traffic that's flowing through. So If we scroll down and have a look at the other ones, we have Azure Firewall Premium now. This is, I'd say, a relatively new product. It's been out for over a year, but you may not have seen it. Just like you may not have tried Yunnan Gold Tips tea, which I highly advise you to do. So this is actually going to add some extra things in here as well. It's also going to add most importantly, and if you ever do the exam, TLS inspection or transport layer security inspection. So it can do certificate interception of network traffic that's coming through and do proper inspection of that traffic itself to do to look for things like not just malware and phishing, but also things like coin mining and Trojan attacks that are actually coming through here. So lots and lots of different signatures in 50 categories there. Microsoft have also added in the Azure Firewall Basic. They've added in this basic category, I think, because people didn't realize how much the standard and the premium version cost. It seems like a simple thing to filter some traffic out, and to an extent it is, but they are layering on that threat protection as well. So cost wise, it does actually equate to a little more than people think. So if you have a look at it on the pricing calculator, be aware that it's not going to be a $1-2 a month thing. It might be $40, $50, $100, $200, $300 a month thing to actually implement into your environment. So this basic tier is just for small to medium sized businesses, and it's actually a much more affordable price point. Hence the thing's a lot cheaper basically. And it's going to include a lot of things from Firewall Standard, but only has threat intel in alert mode on here, and only has maximum throughput of 250 megabits per second, which should be perfectly fine for most organizations, or small to medium sized organizations communicating to the internet. Whereas these Azure Firewall Premiums and Azure Firewall Standards can run into the multi gigabits per second of traffic that they could actually process, which, if you think about it, a firewall that can support multi-gigabit connections is quite an expensive thing. So what we're going to look at within the demo is we're going to build this very basic solution on here, okay? We've got a couple of things. We're going to have a jump box. This jump box is going to have an IP address out to the internet and is actually going to allow me to RDP into it. This jump box is then going to allow me to RDP again internally to this work computer, or this SRV work machine. This SRV work machine is isolated. It only has private IP addressing. The only way that this is getting out to the internet is to go via this firewall subnet to get out. Now, one of the things that's not mentioned within this little diagram here, we'll just zoom in, is there is actually another component that needs to be added. In fact, there actually needs to be added a routing table, which Microsoft call a UDR, which is user defined route. If you see UDR, user defined route, it's a routing table. They just added in complications on there. We attach that to this workload subnet just to make sure that all traffic from this subnet is actually going to get routed through this firewall. Otherwise, any traffic bound for the internet might do that, because built into these subnets, there's actually built-in gateways. So without adding a user-defined route, essentially our workstation server here can go around that firewall to get out to the internet, while the traffic inbound is still coming through the firewall. Very, very important thing to actually configure when trying to configure a completely isolated, secure server. We're then actually going to add to this firewall subnet here and this Azure Test Firewall a couple of rules. One of those rules is to actually block all traffic, and then we're going to allow an application rule. We're going to allow an application rule for GitHub, github.com. Then what we're also going to do is we're also going to allow port 53, because we need that for DNS. And we're also going to allow port 80 and port 443, because that's needed for the HTTPS and HTTP traffic. Okay, so what the end solution will be is the fact that you will be able to connect to this machine, and this machine will only be able to visit github.com. It won't be able to go anywhere else, thanks to the rules that are set on the firewall and the fact that the route table is sending all the traffic through that firewall on the outbound. The other additional configuration we're actually going to make is to change the workload subnet so this actually has a custom DNS. These DNS addresses will be injected into this virtual machine, and we're actually going to add the DNS addresses of 8888 and 1111. In fact, that 888 DNS server, that thing is run by Google, and this 111 server down here, this is actually run by I think it's Cloudflare that actually run this one. And this overrides the internal Azure DNS services. So let's go have a look at it and let's get on with the demo.
The transfer has been completed. We're ready to get underway.
Grand.
So in this demo, what we're going to be doing is we're deploying an Azure Virtual Firewall, and our end solution is going to look a bit like this. We are actually going to have two virtual machines. One virtual machine is going to operate as our jump box. This is one that we are going to RDP into. And from inside this jump box, we're going to hit the next server. This is going to be isolated inside Azure. This server is going to be our workbox and is going to actually have its external routing go through our Azure Firewall. And inside our Azure Firewall here, we're going to put a bunch of rule sets. And these rules are going to apply things like allows and block rules to the traffic flowing from this workload subnet and this work server. So let's get on with that and let's have a look at the Azure portal. So inside the Azure portal, we're going to need to prepare a bunch of information first. So we're going to want to create a virtual network in here. So let's go and select virtual networks and create a new virtual network. This virtual network we're going to call FW VNet, just Firewall VNet, and we'll leave this in East US for the moment. So inside the security elements, we're going to make sure that we have no Azure Bastion or Azure Firewall actually deploying inside here, as we're going to do this later on. And what we're going to do is we're going to drop into the IP addressing section. We're going to select the subnet template here for Azure Firewall subnet, and our starting address is going to be 10.0.0.0, and the subnet size we're going to add in a /26. We don't need a /26, we could even go down to a /32 if we wanted to, but I want to add a /26 in here for simplicity's purposes. We're going to save that, and we're going to review and create this virtual network. So now our deployment is complete. We're going to pop over to that VNet and we're going to build some more subnets on that VNet. So we already have our Azure Firewall subnet here, but we're going to add an additional subnet. We're going to call this one our workload subnet. And the IP address range for this is going to be 10.0.20/24. We're going to add a second subnet on top of this as well. And that next subnet is going to be called jump subnet. And this jump subnet is going to have an IP address range of 10.0.30/24. And we're going to save that as well. Now we've got all of our subnets created, our firewall subnet, our workload subnet, and our jump subnet actually built. What we're going to do is we're going to create a couple of virtual machines inside here. So within this Azure portal, we're going to go and create a virtual machine. We're going to create a virtual machine here. And we're going to build one based around Windows Server 2019 data center. It's going to drop into the existing resource group, and this is going to be our jump box. We're going to leave this deploying into the same region as our firewall, and we'll just change that image down here to Windows Server 2019 data center. We'll leave the default of standard DS2 v3 with the 2 ZPUs, and we'll go and create an administrator account for this. We'll call this local admin, and we'll pop a password in there. I'm going to tell Microsoft that I already have a Windows license for this, and I'm going to make sure that RDP is being allowed through to this network. So on the networking tab, I have to make sure, very importantly, that I'm selected for my firewall VNet, and I'm selected to the correct subnet, that jump subnet that I built before. We're also going to make sure that we have a public IP address attached to this server jump IP address, so that we can be able to RDP to this virtual machine afterwards. RDP over the internet, remember, be very careful with this. Just disable for the moment, and we'll go and review and create this virtual machine. If you want more details on virtual machines, I do have another video on virtual machines where I run into much more information about how they are actually created, how they are built, and a couple of tips and tricks that you've got with virtual machines in Azure. So our first virtual machine is currently deploying out here. And as that's deploying, we're going to create another virtual machine rather than wait around for that to complete. The second virtual machine is going to be our workload virtual machine, the one that will be isolated. And we're going to call this srv-work. And this is going to be chosen in the same region as before, the same operating system as before. We're going to pop in local admin here. Again with the password. We'll make sure that we have RDP enabled with this as well. But on the networking tab, what we have to make sure that we're connecting to is the other subnet, the workload subnet in here, rather than our existing firewall subnet. What we're also going to do is take away that public IP address so that we could only access this machine via using the jump box. So we're going to disable boot diagnostics because we don't need that at the moment because this is just a demo. So now we need to wait for those two virtual machines to actually deploy. And once we can confirm those two virtual machines are deployed, we can then get along with creating our Azure Firewall. Second virtual machine is now going through its deployment. Our deployment is now complete. Let's just go and check on those two virtual machines. So we'll drop into our resource group and we have our server jump box and our server work box. Now what we can do is we can drop in here into firewalls. Now the firewall that I'm about to deploy is not the only firewall that you can deploy in Azure. There are many firewalls you can deploy from the marketplace. So if you're more used to Barracudas or Sophos XGs or Fortinets, you can deploy all of those as managed services inside Azure. So we're going to go into firewalls here and we're going to create an existing firewall. Or create an existing firewall. It will exist after I've created it. So I'm going to name this firewall Azure FW, something very quick and easy. We're going to use the same region as before, the East US region. We're not going to add any availability zones in here. We're going to use a standard firewall SKU for this rather than the premium or the basic SKUs. And we're going to actually use the Firewall Rules Classic to manage this rather than the new firewall policy, as this is just a quick demo for how firewalls work. We have an existing virtual network, and our existing virtual network is FWVNet, and our public IP address, we will need to create a new one for our firewall, but we're going to call this Azure Firewalls IP, and we're going to OK that. We're not going to bother with any forced tunneling, and we're not going to bother with any tags. So let's just create this, and we'll build our Azure Firewall. This will take a while to actually deploy. Azure Firewalls sometimes take a little longer than virtual machines to deploy in Azure. So this could take up to 5 or 10 minutes. All right, so our firewall is now complete. What we also need to do is we need to make a slight modification, not to the firewall itself, but to the way that the traffic actually flows with our virtual network here, and how traffic is actually going to flow from machines that are connected to this virtual network. To do that, we need to go and build a route table. Now, this route table is going to make sure that all traffic from the workload subnet is actually going to route through that Azure Firewall rather than routing through the default gateways provided by Azure. So we're going to call this firewall route, and we're going to leave propagate gateway routes on for the moment. We'll go next on this one, and we'll go and review and create. There's no real settings actually in this wizard for the route table. For some resources that you find in Azure, there won't be any settings within the initial creation wizard, and you'll have to build that thing and then go into it and configure it afterwards. The route table is one of those elements. So let's go to that route table, and we have all of our options for configuration down here. So within here, we're going to go into routes, and we're going to create a new route. And this route name is going to be called FWDG. And the source we're going to select as an IP address. And the IP address will be 0000/0, which is the source is any IP addresses. To be honest, it would be nicer if they had a button that just said any there, but they don't. And so you really need to know to put 0000/0 in there. This is why we need to read documentation or watch these videos. So if we go into virtual appliance, the next hop along, this is actually going to be the IP address. Select virtual appliance, the IP address of our firewall. So we're going to need to drop back here just to go and grab that. So drop back into the Azure portal, drop back into our Azure firewall, pop inside here, and we'll go and grab that firewall's private IP address here, which is 10.0.0.4. So that just means that anything that is connected to the subnet that I'm going to associate this with is going to send all outbound traffic through that Azure Firewall subnet. So once we've done that, we need to actually associate this route table to one of our networks. So the FWVNet, and we're going to associate this to our workload subnet down here. Okay, that. Now that's actually created. Just pop back very quickly, have a look at that VNet over here, have a look at that subnet over here, and have a look at that workload subnet, and we can see that we have a route table FW route actually attached to this workload subnet. Personally, I think it would be nicer if they actually had here the router management, or sorry, the route table management for virtual networking attached in the virtual networking portal space, but they don't. It's a separate option. So one of the things I want to do down here now is configure an application rule. So let's drop back into our firewall, and we'll go to Rules Classic. And within Rules Classic, we're going to go to Application Rule Collection down here, and we're going to add a new application rule. This application rule is going to be called Application Collection App-Collection 01, and the priority is going to be 200 with an action of allow. Within our target FQDNs, the name of this is going to be allow GH. The source of this is actually going to be 10.0.2.0/24, and the protocol will be HTTP and HTTPS, and the target FQDN is actually going to be github.com. So anything coming from this, allow GitHub, anything coming from this source 10.0.2.0 that's going to a HTTP or HTTPS address to github.com is going to be allowed. Let's go and add that resource in. We're also going to configure a basic network rule, because there's no use in actually creating a rule to connect to a DNS address unless we can go and talk to some DNS servers. So we might also need to create a network rule collection here for network collection 01, and we'll give a priority of 200 to this. And down here inside the rules IP addresses space, we're going to do allow-DNS, and the protocol is UDP because DNS runs over UDP. The source is going to be the same, 10.0 820/24, and the destination addresses are going to be 888.8.8.8 and 1.1.1.1. These are both public DNS servers. That first one, 888, is run by Google, and 111, I think, is run by Cloudflare, if I remember rightly. Yes, Cloudflare as public DNS servers, and it's DNS, so the port that runs over is port 53. Let's go and add that in. Now we have both of those rules added in. What I need to do is I need to take our server work machine, our virtual machine over here, and I need to make sure that this thing is using the right DNS servers. So to do that, I'm going to need to drop into the networking space of this server work machine here and select its network interface. On this network interface, I can click on DNS servers, and I can change this from inheriting from the virtual network to custom DNS servers. Otherwise, it will attempt to use the DNS servers that Azure is actually providing it. So I'll add in that 888 and that 111. Now those configurations are complete. In theory, if we go and log into our jump box and then hit our server workbox here, which is running on the IP address of 10.0.2.4, we should be able to see that this server workbox cannot access anything on the internet apart from GitHub, because we put the rule in specifically for GitHub. So let's go and connect to that server jump box. We'll just jump into that via RDP, and we'll go and download that RDP file and open it up. And I'm going to log in with the account of local admin, the one that I created before. And this is our jump box with our public IP address attached to it. Just waiting for it to log in. It takes a second. Once we're actually logged in, we can now use this jump box to jump to the next server along. So let's launch up RDP here. And we're just going to change the display experience here. Drop that down a little bit to 1280 by 1024. And we're going to connect to the computer of SRV-work. And we're going to use the same username of local admin, the one that I set previously. Again, we just need to wait for this to log in. Right, so we're logged in. Let's go and have a look if our rule sets are working here. So I'm just going to bounce up Internet Explorer because Internet Explorer was the only thing that was pre-installed in Windows Server 2019. Since it's Internet Explorer, enhanced security configuration is enabled, so we need to go and get rid of that first. Let's go back to local server and let's go into IE enhanced security configuration and turn that thing off. To be honest, I don't know anybody who actually used Internet Explorer enhanced security configuration, but either way, it was still installed by default. So if I try to go to, for example, google.com, what do I get? Action deny, because reason no rule is matched proceeding with default action, which is to block. But if I go to github.com, which should be the address that we're allowed through, we can actually get to github.com here. After a fashion, this is Internet Explorer, so the website doesn't quite render anymore. But still, that is the setup of a basic configuration for Azure Firewalls. Now, one thing I will mention about these Azure Firewalls is actually the cost. If you're doing this on your local environment, well, not local environment, sorry, your home lab environment, be aware that these can actually start to cost quite a bit of money. $50, $60 a month to actually run. So just be aware of those. There's a lot more that Azure Firewalls actually do. And in fact, there are different SKUs now. There is standard and premium SKUs. And these premium SKUs do have quite a lot of advanced settings for doing things like traffic monitoring and stateful packet inspection of traffic that's flowing through them. But for the moment, that completes the Azure Firewall demo that's required for the Azure AZ-104. I hope you enjoyed that, and I hope you'll see me next time.
And you know the routine, hashtag like and subscribe, and I hope you enjoyed this video and will join me next time. Goodbye.